This slide says choose chef. It's not going to be really like that, but we'll get into details later. It would be mostly about choosing high availability, consistency, and speed. 3 of the things that chef can provide to you, but it can provide even more. First of all, this is going to be, beware, right? So this is going to be a very graphic presentation. There are images that might affect you emotionally. Right there, there is a picture of me. I'm Silvian Cretu. I like to call myself a sysadmin. Sorry to disappoint. But I've always worked closely with developers and QAs. I really like human interaction, despite being in IT and stuff. So I could call myself a DevOps engineer, especially since a lot of companies have this description and job description, and they look for DevOps engineers. 3Pillar calls me a technical lead manager. The manager part means that also I have to approve vacations for the people in my team. Sometimes I'm a developer. Not only I write chef recipes and stuff like that, but I also have my own software written in Python, mostly. I used to do PHP. Some other times I'm a DJ and MC. I'm also, all the time I'm a geek. And for more than 15 years, I've been geeking in the IT field. Let's start with choosing high availability. So I guess we all know Moss. I never actually got to watch the IT crowd because I cannot get past the British humor, but still, I like this quote. I'm a 32-year-old IT man who works in a basement. As Jonathan said, there were times when there were this breed of people like sysadmins that used to work in basements. You can sometimes see them in movies. Fat people with problems on their faces, you know, with dirty t-shirts with stains on them and stuff like that. And people just go to them when big problems arise. So they don't work closely to the teams that they work for. Sysadmins used to care about uptime. I remember there was a website, I think it still exists, called linuxcounter.org. It had a script. You could install it on your own machine, and that script would check the uptime of your machine and then send it to that website, and that website displayed the statistic with servers that had the most uptime ever. So it was a big pride for you to manage a server with a lot of uptime. Now people should not care about uptime. We actually used to care about servers. I mean, when a server went down, it used to be a big problem. I mean, 3 a.m. in the morning, a server went down. Oh my God. On the project I work on, we have servers that die every day. I mean, tens of servers. We don't care. It just happens. So we actually we don't fix stuff at night anymore. And developers used to be at the mercy of a sysadmin. So this happens even today. I mean, I know projects on which developers say, we need a database dump from production. They file a ticket. A few hours later, a sysadmin sees that ticket and he's like, yeah, so today's, I don't know, let's say it's Monday. You can have it by Thursday, more or less. It depends if I have the time. So that's not okay. That's not DevOps. That's not real collaboration. And the fact that sysadmins are lazy can be a problem. Sometimes it's not. I think of myself being the right kind of lazy because I don't like to do stuff more than once. So I automate things. So that's why I would say that sysadmins being lazy is a problem when developers are at the mercy of that lazy sysadmin. But it's a good thing if the sysadmin wants to automate stuff. So the high availability part, I'd say that this is the first thing that a product owner will want to fix. If it's a startup, it's a well-established company, they will want their product to be highly available. If it's not, then people will choose the competition over you. And of course, if you want a product that, we cannot say it will never fail. Servers will fail, But if you want it to be highly available, despite the fact that servers fail, you'll have to get that sysadmin out of the basement and have him work with the developers so that they can together build a resilient and available service. So that's how the buzzword DevOps comes into play, right? So the sysadmin will start to write bash scripts, or maybe Perl, or maybe Python scripts. I have a friend that used to call bash scripts as caveman's chef. So having a highly available service doesn't mean you should care and nurture servers. It just means that servers fail and you don't care because you have something in place that keeps the system highly available. So it doesn't actually mean panicking when disks fail. That will happen in the cloud. That will happen on-premise, on hardware machines. So disks will fail all the time. Let's go to the second part, choose consistency. Again, this is a very graphic presentation. That thing on the right, that's not the agile cost curve because it didn't fit with the colors and stuff. But still, the agile cost curve that you can find online says the estimated cost of fixing a bug in production is 150 times that of fixing the same bug in development. But in order to find the bug in development, you need to have a development environment that is consistent to the one on production. So in order to fix bugs, sysadmins and or developers need to meet the QA. Did I mention DevOps? So sysadmin is developer, right? DevOps. So they meet the QA, and then you hear that thing works on my machine. We don't like that. We will try to replicate the production environment to the QA's machine, so you move that bash script that you created earlier. But the bash script doesn't work on QA's machine because in production you have Linux, QA has Windows or Mac or another version of Linux. In the real world, of course, you will have more than one server if you want to be highly available. The QA person has his laptop, her laptop. What if you want to do load testing? You cannot point 1 million requests to a laptop on the QA's machine. Let's say you have a QA environment on-premise or in the cloud, so it's not on the QA's machine. You want to load test that one. That QA environment doesn't match the production environment because it's expensive. How do you scale it up? How do you scale it up and maintain it consistently? And also, you have the production environment that from time to time will have to handle a lot of load. So you have to address that issue as well. Let's choose speed. So all of this, you have that all the things meme that ends with when do we want it, right? Usually the answer is yesterday, but any product owner will say, okay, you didn't have it by yesterday, how about we have it right now? It should be just fine. There is this other buzzword, the cloud. That was buzzword in 2012. Maybe today is not the buzzword anymore, but still, people think that just by going to the cloud, you'll get the speed that you want in order to scale and stuff, but you still need automation. You cannot just scale because you moved into the cloud. Scaling means scaling also up and scaling down because you will need to scale down when you don't have traffic loads. You need to scale up when you have traffic loads. And you have to do it fast. I mean, during the workshop, I will tell you about the workshop, I can show you tips and tricks on how to scale in 3 minutes and how to scale in 10 minutes. There are things that you can do in order to scale fast. Sometimes by scaling just with bash scripts, you won't do it fast enough. Yeah, bash script is not fast enough, see? It's right there, it must be true. So, in order to achieve this, I would say choose chef. No, I based my whole presentation on this. It's not playing, my God. No, I'll show this to you later. So this is a GIF, but it doesn't play. Maybe it's the bad internet connection. Yeah, but this is my machine. It worked at home, you know. No, it worked on Chrome, but I didn't want to show this in Chrome because I have too many tabs open, so I opened it in Firefox. So if you go to chef.io, it will say IT automation for speed and awesomeness. Chef provides you with an automation in a platform-independent way. So that means no matter what operating system runs on the QA's machine, you can have the same automation on production as on the QA's machine, for example. It provides idempotent automation. That means even if you have a complicated cookbook that does a lot of things, you can run it multiple times on the same machine, and it will only change the things that need to be changed. So multiple runs give you the same result. It will not add to the things it already changed. So that makes it faster, maybe, than traditional bash scripts. It's a Ruby-based domain-specific language, so whenever you write the chef recipe, you write some kind of Ruby code. It has the benefit of transforming your infrastructure in code. So actually, when you start using Chef, the sysadmin starts coding. So that's cool because it puts the sysadmin in the developer's shoes. Also, developers and QAs start understanding the infrastructure because they see it as code. So in a way, it puts developers and QAs in the sysadmin's shoes. So actually, I would say this is where the DevOps thing actually starts to happen. So did I mention DevOps? I guess I did. If you add Vagrant to this mix, you can have an entire production environment running on a single machine. So you can have the developer that has a Windows machine, for example, have an entire production stack with a load balancer and app servers and Redis machines and database servers running on his own laptop in different VirtualBox instances, managed and provisioned with the same chef recipes that provision your production environment. And you can have it in a matter of minutes, and it's similar to the production environment. If you have Bash, Python, Perl, Ruby scripts, you can put them in the chef cookbooks. Beware to keep the idempotents. It's a bit trickier, but you can port them to chef with not much effort. And let's just end this slide by, I'm not a chef evangelist or promoter or stuff like that. I don't get 10% from chef.io just by presenting you these slides. You can try something else if you want. We chose Chef because of its integration with Amazon and Opsworks. But you can and you should try Puppet, for example, SaltStack, or especially Ansible, I would say, is a really, really good contender to Chef. I would urge you to try high availability, scaling, automation, stuff like that, not necessarily Chef. This is a high-level Chef architecture, if you ever encountered it, or if you didn't, so you can see how it works. It's a bit simpler in Amazon AWS, but I'll show you that in the workshop. So you have several people working on Chef cookbooks. They have their own workstations. They have their own OS. It doesn't have to be Linux. All they need to install is a Chef development kit and the text editor. I prefer to use Atom. It has syntax highlighting and stuff like that. They write their code, their Chef cookbooks. It would be ideal for them to store in a version control system, Git or, God forbid, SVN. And whenever they are ready and they want to run those Chef recipes, they should push them to a Chef server. This Chef server will manage those cookbooks, and it will also manage the nodes. The nodes are actual machines, physical, virtual instances. They can be in the cloud or they can be on-premise. It doesn't matter. You will bootstrap them, and then you will run the Chef recipes you want to run on them. This whole thing is a lot simplified in Amazon Opsworks, and I'll show you that during the workshop. Yeah, and that's about it, because now I'm going to present what's going to happen at the workshop. During the workshop, I'm gonna demonstrate you Amazon OpsWorks. The project I'm running on is one of the largest deployers of Amazon OpsWorks, I think, in Amazon. We started using OpsWorks since it was in beta, and I think Chef was at version 9 back then. We have about 1,000 instances that we manage with OpsWorks and about 200 databases. I will show you with the latest version of Chef and the latest version of Ubuntu how to do that. We will pull Chef cookbooks from Git, and I'm going to show you how to do that in a highly available manner. We will also pull them from S3, which is even higher available than Git. We will show you how to do Berg shelf dependency, because you will have to pull maybe cookbooks from different places, and we will do dependency management. We will do all sorts of automation, like provisioning servers. We will go through the server life cycle from start to shutting it down. We will do code deployments. I'm going to show you some tips and tricks for high availability for the application and the provisioning infrastructure, because also the Chef infrastructure or the Git infrastructure needs to be highly available in order for our application to be highly available. I'm going to demonstrate you idempotence and some tips and tricks on how to get faster boot times. We saw that whenever we have a lot of load, you need to scale really, really fast. I mean, sometimes 3 minutes is just slow, but I don't think we got better than 3 minutes. What you gonna do? Use caching. But at this link, there is currently something in there, but by the end of the workshop, you will have all the Chef code that we will write. And yeah, I'm gonna try to open that GIF. It's actually called Explaining Puppet to Management. And the third link is also a cool one, because it shows you how to replicate your AWS OpsWorks infrastructure locally with the same recipes with Vagrant. Another definition of DevOps from DevOps Borat, right? That's actually a real tweet. It's from about 2011. So if you follow DevOps Borat on Twitter, you really have to scroll down a lot to get to this one, because he has a lot of quotes and it's quite funny. This is my contact information. Let me just open that GIF, and in the meanwhile, I'm gonna wait for questions. I'm gonna show you in Amazon OpsWorks, it has triggers based on CPU usage, memory usage, the load counters on Linux, load balancer, traffic, and all other custom metrics that you can use to trigger the start of new instances. It also has time-based instances. So when you know you are expecting traffic, you can schedule for instances to be started. So we don't do that via Chef. We do that via Amazon.
Okay, so basically using Chef, you ask OpsWorks to raise up machines, or you just programmatically know when to raise them up?
We configure OpsWorks in order for it to launch machines. As soon as OpsWorks launches the machines, we provision it with Chef. But Chef doesn't launch machines for us. We didn't configure it like that. That would be a difference between how we do it and competitors like Netflix do it, because Netflix uses plain EC2. We use OpsWorks on top of EC2, because we come from a background in which we also used something else to spin up our machines, but we used bash scripts to automate the provisioning of those machines. So we searched for something similar.
So basically you use OpsWorks also for deployment management and let's say declarative deployment management, like yeah, I want this number of machines up all the time, and if the load increases, scale up, load goes down, and stuff like that, scale down. And basically, this will trigger running some Chef recipes that will provision something or install something or on some VM or some, right?
Yes. Exactly. And indeed, we usually deploy on when we start the machine. So we start almost, it's not really empty machines, because we start custom machines that we packed, we create in advance with Packer, which is also tied with Chef. So the machine is almost, let's say, it has almost all the features that we need. We just deploy some code with Chef as soon as we start it. And yeah, we also run Chef recipes when we stop them for different reasons, like DNS deregister for some machines. And we also use Chef with continuous integration. We have Bamboo for continuous integration and continuous deployment. So whenever people push code to Git, you have a build being triggered, and if that build is successful, then that build will trigger a deployment, and that's all done via API calls and Chef. In a way, yes. We use Docker just for the continuous integration part. We spin up Bamboo agents so that we can build and test our code. And since we build and test different products, because it's a microservices infrastructure, each build has different needs, like different Python version, different Node.js version, and stuff like that. So we actually deploy containers, Docker containers, on those Bamboo agents. We deploy them via Chef, and then when the Bamboo plan starts to run, it will start on a fresh container that is specifically designed for that product that is being built or tested at that moment. And then we destroy the container, and if we don't need it, then we can also destroy the agent or the machine on which that container has run. So our continuous integration and continuous delivery platform is also scaling up and down based on the jobs that it needs to run at that time. Elastic Bamboo, it's called the feature in Bamboo, in which Bamboo can ask from Amazon to spin up EC2 instances so it can do its job. And we deploy Docker in there. We don't use Docker on production. We use it on some service, but I wouldn't call it production because there are so many fires to be put out there currently, and it's managed by Kubernetes currently. Doesn't really work. Brian does that.
Do you want to talk to everyone about Bash being slow and the difference in server setup? So going from 0 to a ready-to-take traffic application server back using Bash versus using Chef?
Yeah. Well, back in the day, we had those, I don't know, it were tens of Bash scripts that used to do things. We kept them in an archive currently, but we never really understood what every of those Bash scripts used to do. Whenever we changed the version of CentOS, it was back then, we had to tweak the Bash scripts again because something had changed. The way, I don't know, sed used to work, or the output of some command that we used to capture as the input in another command has changed. Things started to break. We didn't have a version control system for those Bash scripts because we had to put them in a web interface. It's called WriteScale. If you ever heard of WriteScale, WriteScale is a way of automating clouds. You can automate AWS, it can automate Rackspace and stuff like that. And it's all done via Bash scripts. You put Bash scripts in their web interface and tell it what to do. And you couldn't version them right. In order to make it work, for example, on CentOS 5 and CentOS 6, you had to have if clauses in Bash or different kind of environment settings, and all these workarounds made it be slow. And whenever if you had to run it twice, then different sections of the script actually had to run twice for each run of that Bash script. Chef avoids that. So if Chef sees, well, this resource is already up to date, I won't touch it. then it moves on. So that's what makes it faster. And also, we couldn't use those bash scripts locally, which was quite tricky because people had different kind of machines locally. People used Windows, as I said, so they couldn't run the same automation on their own laptops. We had to do everything in AWS. But now some part of the development or testing can be done locally, which saves some time and money, and it's extremely convenient when multiple people work on the same situation because they can, on the same problem, because they can work on their own machines. So yeah, we moved past that. We initially tried Ansible, but in 2014, Ansible was not production ready. Opsworks was not either, but Opsworks was free. So, and Chef has and had back then a very large user base. So whenever we had problems, we could go online and get solutions to our problems.
Related to this, so Chef advertised themselves, so Chef versus Ansible is like Chef is declarative. You tell him what you actually want to achieve and not how, right? Yeah. So how much, so I'm checking my colleague here because he tells me all day I'm writing some Ruby code. So how much, let's say, actually scripts do you have to run instead of using stuff telling Chef to what you want to achieve?
Quite a lot, actually. When you just go through the provisioning phase, let's say you need, indeed, you just declare to Chef how your machine how you want your machine to look like. You want these packages, you want these ports open, you have these services that need to be started, and stuff like that. So you just declare stuff, and that's simple. But whenever you have to do complicated stuff like deployments or interacting with AWS's API, for example, because you want to do tricky stuff like configure triggers for scaling up and down. Of course, Opsworks will do the scaling up and down for you, but you can configure those triggers from Chef. Or you want to, let's say you do DNS balancing. You start a new machine, you register it in a DNS provider via an API call. So in that case, you will have to do programming. And the simplest way to do it is in Ruby, because Chef already has opened the Ruby interpreter for you. So if you have the interpreter already up and running, you just use AWS's Ruby SDK in order to do the registering. So you have to actually start coding in Ruby, which is not necessarily fun because it's invented by a Japanese, so it has to be weird. But yeah, I would say I would say it's a lot of scripting. And we also, like for example, I don't know if you used New Relic, which is a tool for monitoring application performance. Whenever we do deployments, for example, there is a thing in New Relic called New Relic marker. You can mark the moment in which you've done a deployment. So you have graphics that show you how your application performed, then you have a straight line saying now you've deployed something else, and now the application performs that way. So it's really cool when you do a deployment to mark it. To interact with New Relic's API, well, we wrote bash scripts. It's the simplest way to do it. So we had to incorporate bash scripts in Chef.
Thank you. I also am hearing a lot about Chef and Windows, PowerShell. So do you have any experience with that?
I'm not touching that subject. So, yeah, but I said, I'm not a Chef evangelist. I'm not getting 10% for promoting Chef. You can try Ansible, and you should try Ansible. But on the other hand, you should never try Windows. Dude, no. I'm a Linux evangelist, yeah. I don't get 10% from the Linux Foundation either, but still I support Linux. So I don't think I've ever tried Chef with Windows. It definitely works. It says on their website, but Ubuntu runs on Windows now, since they They made a pact with the devil. So hopefully this presentation will be uploaded to SlideShare, which is owned by LinkedIn, which is owned by Microsoft, which is owned by the devil, as I said. So, so you'll have the links at some point. Thank you.